First we had all-trans retinol. This ol was an alcohol. That became a cis alcohol. That became a 11-cis aldehyde. So in the option, what is the integrated part of the vitamin A? It is 11-cis aldehyde. But when you broke it ultimately over a series of steps, what you get is an again aldehyde, but it is all trans. So when I break it, it will be all trans aldehyde along with that of opsin. But when they have to be with opsin, it will be 11-cis aldehyde. For combining both to form rhodopsin, it is 11-cis aldehyde. But when you break them, what you get is all trans aldehyde. Okay, now watch very carefully what is happening here. Now this metarhodopsin 2 will help in the conversion of GTP to GDP. At the same time, transducin GDP becomes transducin GTP. Now this is where most of the students will have difficulty in understanding what the vitamin A chapter is telling you. Here I want you to understand one common physiological concept of excitation, stimulation, and your action potential impulses. Let's stop here for a while and we'll go take a detour to explain something and then come back here. Now look at this. If this is a simple membrane of a cell, generally you will be having a plus charge outside and a minus charge inside. One of the common reasons for such a thing is the presence of your sodium potassium ATPase pump. Why? Because there is always some kind of variations or weirdness about this particular sodium potassium ATPase pump. You will always have 3 sodium getting pumped out at the cost of 2 potassium pumped in, and this is against the concentration gradient, right? So you have to use an ATP. So ATP breakdown is done by the enzyme called as ATPase. So always plus charges will be more outside, minus charges will be inside. Now this is called as diametrically opposite charges. Outside is plus, inside is minus. This is referred to as polar state. Why do I call them as polar state? In the globe, this is North Pole, this is South Pole. The North Pole is called as Arctic Pole, this is Antarctic Pole. It means Arctic speaks about the presence of polar bears. You have polar bears on this pole, polar bears are absent in this pole. So both are diametrically opposite in case of culture and the presence of habitat. That is what we are trying to understand here. When I say a cell is a polarized cell, the outside is plus and the inside is minus. This is the resting state. Now, if at all some kind of stimulus descends like a lightning, that stimulus will make sure this particular sodium outflow can be blocked for a while potassium can actually go in. When the potassium tries to go in, you will be having the plus charges trying to slowly fill inside. So that means the first plus turns into minus. So slowly every single plus will start flipping into minus, minus and minus at the cost of the inner minus becoming plus, plus, plus and plus. Now this is called as depolarization. What do I mean by depolarization? On the hitting of a stimulus, because of the channel opening or altering in the channel opening, you have the outside plus turning into minus and the inside minus turning into plus. Now this depolarization can be sent out as a stimulus which can become an action potential, and that action potential, if it goes to a muscle, it can cause contraction. If it goes to a gland, it can lead to secretion. So generally in physiology, what do you understand? Whenever an action potential is found, if an action potential is generated, it is because of depolarization that can make either contraction or secretion happen. Now, in case of your retinal pigmental epithelium or in case of rods of your eye, you will be having hyperpolarization giving rise to action potential or activation of the end result. So hyperpolarization determines the whole activity in case of your rods. This is an exception. So if you remember this exception, understanding vitamin A's activity can slightly become easier. So we'll come back here to the picture right now. So after discussing that part, we're coming here. Look at this. Here the transducin is actually the G protein. Transducin is nothing but the G protein. This G protein is inactive when it is bound to GDP. Ask yourself, who is more energetic, GDP or GTP? It is GTP. So if you want to convert the inactive G protein into an active G protein, the only thing you have to do is convert the GDP into GTP. So when the G protein is bound to GTP, it is active, and when it is getting dephosphorylated. That is, with the help of a phosphatase activity, if the GTP breaks and goes back to GDP, it can become inactive. So this is a continuous cycle of inactive to active, active to inactive, inactive to active, active to inactive. That is the beauty of any kind of G protein right now, right here. Okay, now I want you to understand, when the metarodaption happened, this converted the GTP that is outside into GDP, so that GTP's phosphate was given to the GDP in the presence of transducin. So transducin GDP becomes transducin GTP. When the transducin GDP